All right. Yeah, streams are looking good. Both on YouTube and on Twitch. Right. So back again for day number 5. Let's see. There we go. So yeah, back again for day number 5. I didn't bother to change to context today, so you'll have to live with the annoying glare in my glasses. Hopefully it won't be too distracting. Yeah, I have set up my folder here again with nothing in it. Haven't looked at day 5 yet, so this will get interesting. Day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. Right, so you have a bunch of crates of different stuff. Some of them contain snacks, but they are buried in a mountain of other crates. The ship has a giant cargo crane capable of moving crates between stacks. So kind of a Hanoi Towers kind of scenario. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. Right? The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where. And they want to be ready to unload them as soon as possible so they can embark. Wait, so they're shuffling crates, but no one knows which crate goes where? That doesn't sound too useful. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, which are puzzle input. For example, so apparently stack 1, 2, and 3 with end set D, C, M, and P. And then move one from 2 to 1. Move 3 from 1 to 3. Move 2 from 2 to 1. And move 1 from 1 to 2. Right. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is at the bottom and crate N is on top. Stack 2 contains 3 crates. From bottom to top there are crates M, C, and D. Finally, stack 3 contains a single crate, P. Then, the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, one crate is moved from stack 2 to stack 1, resulting in this configuration. Right. So we move 1 from this stack to stack number 1. We move the D over to stack number 1. In the second step, 3 crates are moved from stack 1 to stack 3. So this step here. Crates are moved one at a time. So first, crates are moved one at a time, right. So the first crate to be moved, D, ends up below the second and third crates. So when it says move 3 from 1 to 3, so we had moved this over there. So it takes this, puts it there, N puts that on top, and Z and puts that on top of there again. So you end up in this configuration. Then both crates are moved from stack 2 to stack 1, again because crates are moved one at a time. Crate C ends up below crate M. And finally, one crate is moved from stack 1 to stack 2. So that could be simplified with just moving 1 from 2 to 1. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you should combine these together and give the elves the message CMZ. After the rearrangement procedure completes, what crates ends up on top of each stack? Right. So a bit more parsing, it seems, than we've had in the previous couple of days. We have to like get these out from the string, and we have to, of course, parse this into some kind of data structure. And of course, our input, as usual, is bigger than it normally is, or than the example. All of these, yeah. So there are 9 stacks that are single digits and all single characters. That makes parsing a bit easier. But we do have the ability to move more elements than 9 elements. So that this part of the parser needs to deal with that. Right, let's store this in here. I think we'll still stick with some simple parsing here. So basically we want to have some kind of data structure for stacks, and have sort of a list of stacks, and then we have to parse these and figure out what to do, what to move from which stack to which other stack. But since these have to go in the opposite order, we can implement them as sort of simple loops. So that might simplify things for us a bit. But this is an unusual sort of parsing situation for this kind of puzzle. But of course, we can do this a couple of different ways. We can do a full-on parsing thing using a parser combination thing and do all of that. Or what I'm thinking we can do is some simple sort of string searching magic logic. So let's try that. Let us first create our stacks, which is a sequence of characters. So each stack is a sequence of characters, and we have multiple stacks. So we have sequences of characters. And now let us do right, so we need to do some inserts. So I'm thinking to get the order straight, I want to parse these like top down, just reading this whole thing in line by line. So I'm thinking something like find this character, figure out which line, then grab this character, find the next one. So we know the position corresponds to a line, and find the next one. But that would mean that they're all sort of reverse order. But that shouldn't really matter. So if we add them at the start, we would just have to remove them from the start, or we could insert them insert each character at the beginning, which I guess would be the better choice. So if you have a look in the secutils module, this is the module that sort of sequences are built in, but a lot of the NIM standard library has this like utils postfix, which basically means that this is a package you can import if you want some like convenience features around whatever you're looking at. So here we have stuff like delete, insert, stuff like that. And we're going to be using insert because we want to insert these at the beginning of our sequence. So let's loop through this, all the lines in the input. If our line, so the end condition for this parsing is when we run out of, when we can't find one of these characters on the line. That means we've reached this line and shouldn't go any further. Of course, in the string utils package, which we've looked at in the previous episodes, or the previous days. These aren't really episodes. Here we have the find, which can find a character in a string, starting at a position, which is useful. And exactly what we want. So let the position be line.find, and we want to look for this character. So the beginning of one of these characters. And really we want to do this as long as the position is, so we want to do while pos is not equals to -1, and we do this. So we grab the position. If the position is not -1, then, or we'll loop as long as this is not -1. -1 means that we didn't find anything, and we update that. But if the first one, if -1 is -1, then we need to break out of this loop, because that means we have encountered a line where we don't have any of these characters on the line. Just before we get going, I want to copy this and create a so we want to paste that in from the clipboard, make sure our alignment is good, and write this out to testinput.txt. It actually looks, this is interesting. So these are actually padded to the end of the line, which means that we could actually do indexing. I didn't realize that these were padded. So we could actually look at the index for each of these and find if it's an uppercase letter. If it's not an uppercase letter, then we simply ignore it and we break on an empty line. But let's implement this, since we're already doing it. So let us echo out just line, the line position, and echo out the position. Actually, let's do it all in one line. And let's, did I update that? No. So for the test input, let's run this. Ooh, that was an infinite loop. Because we forgot to start our find at the position that we're currently on. So as I said, this takes a string, a character, and a start. And we want to pass position in as our start. and we need to import string utils. We're also going to need secutils, but we haven't used it yet. Oops, still an infinite loop, so I'm guessing we have to start at position +1. Otherwise, it just finds the same one over and over and over again. Here we go. 404048, which corresponds to 4, and then end of this one, 04048. So it seems that if we divide by 4, we will get the index in our sequence. Actually, let us have some fun. Let's do an array. So typically you would do something like this, an array of 9 sequences of characters. And we can start by doing this. And now we can say that the stack at our position divided by 4, that means this 4 becomes a 1, this 0 stays a 0, this 8 becomes a 2. So that is the correct index. So now that's our sequence. And then we want to insert, and if you look in the documentation, this insert takes a var sequence, a source, something to add something from, and a position. There should be a version of this that takes only a single element as well. Maybe I actually don't need secutils for that one. So we want to insert the character at line position +1, because at position, as we can see here, is just the thing that we found. We want the next character. So we want to insert this, and the default is position 0. So first in the sequence. So if we do that, and if we now, after our loop is done, echo out our stack, we should see that our first stack, our 0th stack, contains sed and n, which matches sed and n. And then the next one should be mcd. We have mcd, and then we have p, which is p right there. Now, all of these, so these are indexed from 1 to 3 in this case, or in our full input, they are labeled 1 through 9. And of course, we now, by default with our array, index these from 0. But what you can do in them, you can say 1.9, and that will actually index the array from 1 to 9 inclusive. Of course, we now need to add 1 to this, because this creates 0, 1, and 2, and we now want to insert them at 1, 2, and 3. But if we run this, output looks the same as before, because we haven't really changed anything other than the indexing. So if I now do stack number 1, that is the sed n stack and not the mcd stack. Which is just, I mean, if we add a 1 here, or if we add a 1 in the instructions, doesn't really matter. But I just wanted to show off that you can actually do 1 indexing in them if you for some reason want to do that. Right, so now we're looping through all of these. We're finding this. if the position is -1, we break. But this iterator is, so we can't run this again, then we'll start all over again. So what we're actually going to do, we're going to just remove this line. That means we'll keep going at the end here. And what we can do, so after each line, we now have, so if the position is equal, it will always be equal to -1 at the end. Well, so all of these lines start with the word move. So we can actually just do this and say, if line starts with move, echo, well, just echo out the line. And we will see now that we're going to loop through our input and we're going to print out all the lines with our move commands, which is pretty nifty. And if we then split this on the space character, we will now see that we have the word move, 1 from 2 to 1. And since our input is so regular, it's only the word move, it's move X from Y to Z, we can do it with a simple string split. We could, of course, also use something like stir scans, or of course any of the like parsing things. And in this case, we can do something like this and sort of grab them out, and these can actually do automatical. Okay. Let's do this then. That seems way more ergonomic. So let's have the move X from Y to Z. So we have count. They need to be in brackets. No. We have count. We have stack 1 and stack 2, which are all integers. And then we can run this scanf. All of our lines are going to match, but we could of course wrap it in this kind of construct. So we can do if scanf our line, and then we match that to move $I from $I to $I as count stack 1 stack 2. Now we echo out count space stack 1, another space, and stack 2. And we need to import the scanf module. No, it's called stir scans. Yes. So if we now run this, we will see that we have what was earlier move 1 from 2 to 1 is now just 1 to 1. Move 3 from 1 to 3 is just now 3, 1, 3, so on, which is pretty nice. So now we know that we want to move 1 from one stack to another, and we want to do them one item at a time. Of course, we could do this by grabbing slices and reversing them and all that kind of stuff. But by far the easiest way of doing this is just for element, maybe, in so we're moving X from Y to Z. Actually, just for I in 1 ... count. So this is going to be our element, Actually, we don't need to keep this variable. So from 1 to count inclusive, so that means if count is 1, then it's just going to do this once. And just to double check this, we can just loop our echo statement. So this is echoed once, this is echoed 3 times, this is echoed 2 times, and this is echoed a single time. That works fine. And now we actually need to do our moving. So we're moving, let's actually rename these. Has from stack. Ooh, didn't like that. It's from stack and our to stack. To stack and our from stack. And of course we need to use these names down here as well. There we go. I was just about to save this file and run this. And if I do, you can see that this still works. Even though I forgot to capitalize this S. And that is because nym is both case and underscore insensitive for the most part. So these identifiers are actually all the same. There was some debate about removing this from version 2 of nym, but luckily that got dropped. Personally, I find it a really nice feature that I wouldn't want to see removed. It just means that I can write the library in snake case, you can use it in camel case, or the other way around. It just means that I can write code myself that looks consistent in style, even though I import libraries which don't use the style that I prefer, which I find is a nice thing. Right. So for this, so in nym, we could have said I, and then we could use I in our for loop. But if we just do an underscore, it will just not assign this to a variable, but it will still do it this many times. That just helps us not having to come up with a name. And if we had an outer for loop, like for example here we have a for loop and we use the word line, but if we had used I, for example, I can reuse I here without shadowing the outer variable. It's just a nice way of saying, like, I don't care about this, just assign it to whatever. Don't make it available to me. So now we need to remove elements from the end of from stack and adding them to stack. And if we have a look here, I believe we have a pop. Ooh, we don't. Wait, that might just be in the standard library. So to stack.add from stack.pop. Yeah, apparently don't have. Why is this so unhappy? Wait, what's the actual error here? Pop takes a varsec and returns to T. Required type for S is varsec T, but expression from stack. Oh, right, of course. From stack is an index into our stacks array. And since we started our stacks array at 1, we don't have to subtract 1 from these. Oh, I apparently just called this stack. There, that should fix it. I should be able to do that. Yeah. That runs without errors at least. So here you can see I'm using command syntax. We could also, of course, call it like this. But yeah, let's just one way of calling functions in them. It's the same one that I use for echo. You could also call echo with brackets if you wanted to. But I tend to prefer this style. Mostly because on a Norwegian keyboard you have to hit Shift 8 and 9 to get the brackets. So the more brackets I can skip, the better. But as you will see, I don't do it every time. Some things I bracket. I'm a bit inconsistent about it. But yeah, that should be everything we need. So if we now echo out our stacks, these should be what we expect. So CM and PDNZ, which should be CM, PDNZ, which is what we wanted. So now we can do for a stack in stacks, if stack.length is not equal to 0, standard out.write the stack at position stack.high, and then at the end of that just write out a new line. So echo adds a new line automatically. The write to a file does not. So standard out, which is a file or a file-like object, can run write, and that doesn't add a new line. So we can just keep writing these. Stack.high is basically just the same as length minus 1. It's just the highest index. And the stack.length is not equal to 0 thing. Just make sure that we don't error out trying to read anything from these. So that should give us CM said, which is what we expected. So if we now take this, run it on our input, and actually we didn't end up using sequtils. I thought this insert and possibly also pop was from the sequtils module, but apparently those are just in the system module, which is included by default. So after having run through it, I got this output, which should be our right answer. That's the right answer. 1 gold star closer to collecting enough star fruit. Nice. So part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Uh-oh. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crate mover 9000, it's a crate mover 9001. It's way better than the old crate mover 1006. I guess that might be a reference to an older puzzle. The crate mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to stack 1 behaves the same as before. So moving a single crate works the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order, resulting in this new configuration. So since it grabs these 3 crates, they retain their order, so instead of moving them one by one, it moves them DNZ. Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. Finally, a single crate is still moved from stack 1 to stack 2, but now it's crate C that gets moved. Remember earlier this was flipped, and that double move didn't really do much. In this example, the crate mover 9001 has put the crates in a totally different order, MCD. Before the rearrangement process finishes, update your simulation so that the elves know where they should stand to be ready to unload the final supplies. After the rearrangement procedure completes, what crate ends up on top of each stack. Right. So let's copy our part 1 solution over. And then let's open our part 2. We need to refresh. And let's run this on test input so that we can verify our results. So instead of looping through and moving them one by one, we now need to take a chunk off and move them to a different one. I wonder if we have in SecUtils a delete, which takes multiple, right, yeah, we have first and last delete. The slice version is the preferred one. So right, we can delete multiple entries from a stack. So instead of doing this, we do stacks are to stack, and I don't think we can add. Now we actually need the SecUtils. I don't think we can do add. I think we have to do insert, because I don't think add can take a sequence, but we'll figure that out soon enough. The from stack, and that is count elements, which means that we need to go so we need to go to stacks from stack dot high, and we need to go from stacks from stack dot high minus our count. I'm not sure if this, right, so adding apparently doesn't allow us to do that. We have to use insert, and we want to insert this at position stacks to stack dot high, so at the end of the sequence. Let's put this in brackets. What is it complaining about now? Sequence of characters T. What? What is it? Sometimes the LSP thing messes up. Oh, we have an int and a slice situation here somewhere. So this should of course end there, and so we're basically trying to do an index from, I had goofed up, so this here we are getting a stack, and I was trying to get an index from the from stack integer. Right, that creates NPD, which if we look at our input, it won't be the correct one because we never remove anything. We just insert from one stack to another. So if we have a look at the full stacks, we now have way too many elements in our combined stacks. But this is getting a bit repetitive. So let us do a little trick here. From stack high is simply equals to the stacks from stack dot high. That means we can do this as from stack high. We can do this as from stack high. And oh, that was the 2 stack. Oh, we have to say that this returns the integer. There we go. So this is basically a template, and then will get expanded on compile time. So this is basically just an alias for this, and it will get expanded on compile time. But we also need to delete that same range. So let's just maybe not call it range. Let's call it crates. So we want to grab this range right here and just call it crates. There. So right now it takes from the from stack, it takes the crates and it adds them to the end of stacks 2 stack. I wonder if the insert doesn't say. I was wondering maybe if we passed -1 into there, it would add it to the end. Guess we could try. This might just be a runtime error. Yep. So never mind that then. But now we need to, of course, remove this from the from stack. So we want to delete the crates from the from stack. Now we should actually get the correct answer. Ooh. Right. So these indexes are obviously not the same for the from stack and the to stack. So let's call this from crates. No, to crates. And wait, that's confusing. From crates and to crates. So we want to grab the from crates from the from stack. Wait, why didn't that work? From stack dot high is count from stack dot high. So deleting that from stack should work just fine. Let's have a look at this. So we're trying to remove 1 and 2 from this one. That should remove these two. 0 to 3. That. And then it gets a -2. On line 17. Oh, it's on this line. Wait. I think that runs just by pure accident. Right, so I was correct in creating from crates and to crates. I just confused myself. But we need to do a little bit of this, a little bit of that, and this should actually grab from stack. This should actually grab the from crates. No, the to crates. And this should grab the from crates. Wait, that makes no sense. We're always removing the same ones. Why is my logic failing me here? So this gets us the highest index. So we want to loop to the highest index. And we want to loop... Ooh. If we remove 1, we want to loop from the highest to the highest. Not the highest minus 1. Or the highest plus 1. This should work. But it didn't. I'm sure this is super obvious why this doesn't work. But talking and programming at the same time is surprisingly tricky. So it prints out the, what was the order I printed this out? To stack, from stack, and the crates. So take the first crate from here, move it to there. Oh. Inserted it at a weird position. That might actually be our issue. We want to insert at length and not at high. There we go. So I was inserting them one lower down than I meant to, which meant that when we're adding to an empty sequence, we try to add it outside of the sequence, which obviously won't work. So read your documentation. Probably says in there. So now we end up with MC, PZ, and D, which should be MC, PZ, and D, and the end result MCD, which is what we get. So that seems to all be fine. And if we now run this on our full input, we hopefully have our answer. And there we go. That's the right answer. You're 1 gold star closer to collecting enough starfruit. Oh, and the bay continues, but now we have more forest around us. Nice. So yeah, this I managed to trick myself here a bit, which caused a little delay, but overall not too bad. Of course, this, so in NIM with sequences, taking slices and deleting from sequences and inserting into sequences are all kind of expensive operations. We make a lot of like memory copies, copying things in and out of the sequences with crate. So this right here, where we grab the crates, that will create a new sequence, which is like allocated memory. So this won't be the fastest solution. It's not the most elegant solution, but it works. It's pretty easy to write. And I mean, it's not, for an example like this, which is super small, if we run this, it should be, yeah, it takes 0.002 seconds. So it's not like terribly slow or anything. But that was that was basically it for day number 5. Yeah, I'm not sure if anyone. I haven't had a look in the forum thread yet, so I'm not sure if anyone is doing something fun here. Yeah, edit of code. Yeah, someone, or not someone, Zoom, complained that the leaderboard does not really represent NIM usage, because a lot of people have signed up in previous years and are now using other languages, either just for fun or like have switched to other languages. I said even some of our moderators use different languages. I mean, we all like to play with different languages. So yeah. Yeah, I'm guessing maybe it is Miran who uses another language. Yeah, exactly. So he's in multiple ones because he has in previous years solved them in that different or in that language. I mean, I'm in the official NIM leaderboard, but the problem is that, I mean, I do these after work, like late in the day, so I won't really reach the top of the leaderboard. Anyways, I'm not sure where I am at the moment. Oh, this is the full one. So I think I'm in both of them. Your score depends on how fast you do them after they're published. So yeah, I'm 35th. Basically it. How have you been slower than I have? Have you? Oh, maybe one of the previous days. I was like, have you been reading along, doing like writing it at the same time? And this is down to typing speed. But no, of course they have probably done their previous ones later in the day than mine. But yeah, pretty much the only people below me are people who haven't done all the stars yet. Who's actually on top? Michael Reese. I'm not sure who that is. Wait, Narayan is on ours. Oh yeah, but he does them in a different language. Who's this guy? Does some stuff in NIM at least. Not sure if he does his advent of code this year in NIM. Doesn't seem to have his thing there. Anyways, that's pretty much it for today. I hope you enjoyed the stream, and I hope to do a new one again tomorrow. So yeah, that's it for